Hello grade 6, this is Mrs. Height. Today we are going to be working on the lesson titled Dependent and Independent Variables. You will be completing pages 91 and 92 in your Jump 6.2 book. Our learning target for today is I can identify the independent and dependent variables on a graph. Before we begin, I would like to review variables. In science, we have learned about 3 types of variables. The first is the manipulated variable. You may remember that the manipulated variable is the thing that is changed in an experiment. Remember, we can only change one thing at a time. That ensures that we have a fair test. Our second type of variable is called a responding variable. A responding variable is the outcome or what is measured in your experiment. Lastly, we have controlled variables. Controlled variables are what stay the same, and there can be many controlled variables. Scientists work really hard to keep a controlled environment. In this lesson, you will notice that we are introducing some new terms, independent and dependent. These are not new concepts, but they are new words. An independent variable is another word for manipulated variable. And moving forward to junior high, you may hear both. So, let's consider an experiment with maybe 3 little plants. So we start these plants off, all very small, maybe they each have 1 leaf, the same type of plant. And now you, as a scientist, have decided to do an experiment. To do an experiment, you are going to change or manipulate one thing. You may choose to manipulate the amount of water that this plant is getting. So your first plant will get a little bit of water. Your second plant will get more water, and maybe your third plant will get no water. That is up to you as the scientist to decide. So the manipulated variable or the independent variable is the amount of water. The dependent or responding variable is the effect or the result. That's what you're going to measure to see the effect that the amount of water is having on your plant. So dependent variable is another name for responding variable. So in this case, you will be measuring the height of this plant. The height of the plant is the responding or dependent variable because it depends on the amount of water the plant is receiving. As a scientist, you may also be curious how fertilizer will affect your plants. If you choose to test how the amount of fertilizer will affect your plant's growth, you would do a second experiment. In this experiment, each plant would get the same amount of water, and the only thing that would be manipulated or changed would be the amount of fertilizer. So the amount of fertilizer is the independent or manipulated variable. Again, you are going to measure the height of the plant as a way to see if the amount of fertilizer changes the growth of the plant. The height of the plant is the dependent or responding variable. It depends on the amount of fertilizer. The independent variable or the manipulated variable is most often graphed on the x-axis. So you can see on our x-axis we have the amount of fertilizer in grams, 10 grams, 20 grams, and 30 grams. The dependent or responding variable is plotted on the y-axis. In this case, the height of the plant in meters. So we can see overall, as the plant receives more fertilizer, it grows taller. Let's use this information to answer a few questions in JUMP. Please turn to page 91. Let's look at question 1 together. It says, the graph shows the cost of making an international phone call with a cell phone company. International means to another country. Before we read each question, let's examine the graph. We can see on the x-axis, we have the length of the call in minutes. So a call that lasts 1 minute, 2 minutes, all the way up to 7. On the y-axis, we have the cost of that phone call in dollars. So if we remember from the previous slide, the independent, I'm going to put an I, is graphed on the x-axis, and the dependent is graphed on the y-axis. So the cost of the phone call is dependent on the length of the call. Well, that makes sense. You would expect that the longer the phone call, the more it will cost. Let's read part A together. If you talked for 2 minutes, how much would you pay? All right, remember the length of the call is on the x-axis. Let's find 2, and we can see that a 2-minute call will cost $4. Part B, what is the cost of a 1-minute call? Again, we're going to go to the x-axis, length of call, 1 minute, and we can see that would cost $2. Lastly, part C, how much would you pay to talk for 10 minutes? I would like you to try part C on your own. You're going to either need to extend the graph or determine a pattern. If you would like to look at a pattern, you may make a chart. So on one side, you could have the length of the call and then the cost in dollars. So we know a 1-minute call costs $2. A 2-minute call costs $4. A 3-minute call costs $6, and so on. So if we go all the way up, to 10, we will find our answer for part C. You may notice a pattern in the second column, the cost of the call. We can see that each time it is increasing by 2. So each minute costs $2. 2, 4, 6, 8, 10, and so on. Complete the chart to find the answer for part C. I would like you to try question 2 on your own. Remember, notebook questions require a separate piece of lined paper. You may not have room to answer this question in your JUMP math book. Let's look at question 3. We will do part A together. Tom runs a 120-meter race. Let's look at the graph. We have the time in seconds on the x-axis. The distance from the start in meters is on the y-axis. Part A says, what are the dependent and independent variables? Well, let's write our answer here. The dependent variable, remember, is most often located on the x-axis. That means our independent variable would be time. The dependent variable is most often listed on the y-axis, and it is the distance from start in meters. All right, does that make sense? Certainly does. The distance from the start depends on the time the person has been running. Please answer questions B and C on your own. Question 4 is about the cost of renting a bike. Please try question 4 on your own. Question 5. This section of question 5 is the instructions. We will read this together and try part A. It says, for each table, write a rule that tells how the input changes, how the output changes, and the relation between the input and the output. That's a lot. What this is saying is it has 3 parts. The first part, how the input changes. So we will notice that the first column is labeled input. If we look at one number to the next, we can see that the input is increasing by 1. And that's exactly what they have written. The numbers in the input column increase by 1 each time. The second part of the question asks how the output changes. The second column is labeled output. Let's see, 3 to 6, we add 3. To go from 6 to 9, we also add 3, and the same for 9 to 12. So, they wrote the numbers in the output column increase by 3 each time. Finally, if we look at the input, how do we get to the output? So I'm going to draw it again right here. It's getting a little bit messy. So we have the input and the output. So to go from 1 to 3, we could add 2. 1 plus 2 is 3. However, it must work for each input. So 2 plus 2 does not equal 6. What else can we do to go from 1 to 3? Well, we can also multiply by 3. 1 times 3 equals 3. Does that work for our next input? 2 times 3 equals 6. It sure does. 3 times 3 is 9. 4 times 3 is 12. So, you must multiply the input by 3 to get the output. Let's try part A together, then I would like you to try part B. You may cross out C and D. All right, remember part 1 is describing how the input changes. So the input increases by 1 each time. And you'll notice that's consistent in each question. So the input increases by 1 each time. The second part of the question asks about the output. So what do we notice about the output in part A? 6, 12, 18. So it's also increasing. If we look closely at these numbers, we'll notice that they're increasing by 6 each time. All right, lastly, how can we go from the input to the output? Let's try multiplication. To go from 1 to 6. 1 times 6. Whoops, I always forget I can't write on that side. Let's write right here. 1 times 6 equals 6. What about 2 times 6? Yes, it equals 12. And lastly, 3 times 6 equals 18. We have found our rule. So multiply the input by 3 to get the output. Please try part B on your own, and remember there are 3 parts to the question. I would like you to cross out question 6, and that is the end of our lesson about dependent and independent variables. Have a wonderful day.